Hello and welcome back to another factoring video. And in today's video, we're going to talk about GCF some more and maybe some unusual greatest common factoring problems. But we're going to start off with something that hopefully you'll be able to do from watching the last video. But we'll start off easy, and then I'm going to introduce you to another kind of GCF that you might not be familiar with. So without further ado, let's go ahead and jump right into it. So the first problem that we're going to look at is 6x to the fourth power minus 18x cubed plus 12x to the second power, and we want to factor this thing. So if you recall, we want to kind of do this in parts. We see we have three terms here because there's an addition and a subtraction, and there are three things that are separated by those. And let's erase that equals before we do it. So then we're going to look at the numbers, we'll look at the variables, and identify what is the largest number that all these numbers can, so the largest number that they all can be divided by evenly. So if we look at this one, and look at this one, and look at this one, you know, oh, well, they're all divisible by 2. They're also all divisible by 3. They're divisible by 6, and actually we can't go beyond 6 because that's as large as this number is. So that tells me I can bring out a 6. So now I'm going to look at the variables. Well, if I have 4 factors of them here, 3 factors of them here, and 2 of them here, the most I can take out is 2 of them. Now, if you remember with the scratch work, you just divide everything by that greatest common factor. Six divided by 6 is going to go away, and then we have 18 divided by 6. Well, that's just going to become a 3. 12 divided by 6, that's going to become a 2. Now, if I have 4 factors of x and I'm taking away 2 of them, that means I have 2 of them left over. And then if I've got 3 of them and I'm taking away 2 of them, that means I have 1 of them left over. And then if I've got 2 of them right here and I'm taking away 2 of them, then I'm going to not have any left over. So just going, I had 4 here, I'm dividing out 2, which means I have 2 left over. I've got 3 here, I'm dividing out 2, that means I have 1 left over. So now let's write the result. So I didn't divide by a negative number, so all my signs are going to stay the same. Now 6 divided by 6 is 1, and we just have the x squared. Oh, let me change the pen, sorry. We'll have an x squared. And then we have 18 divided by 6 was 3. Remember, there was a minus here, so negative 18 divided by 6 is really a negative 3. So we'll have a minus 3 there, and then the x. And then we have a plus 2 that was left over from the last one, so we factor out a GCF. Now, actually, sometimes you might be able to do a little more factoring here on the right, with what's left over after you factor out a GCF, because that's always the first step in the factoring process. So because we're just talking about GCF, that's where we're going to stop. So let's take a look at another one. So let's say we wanted to find the greatest common factor with, we'll say, x raised to the 3/2 minus x to the 1/2. So believe it or not, you can actually factor out a greatest common factor even when you have fractional exponents. Now, fractional exponents are really just radicals. So if you'd like to see a little video on that, please let us know in the comments. Now, to make more sense of this, let's write these numbers as decimals. So whenever we did the factoring process up here, we only took out 2 x's because that's the most this last term had, and the other ones, each of the other terms, there was an x cubed and x to the fourth. Those exponents were larger. So what we ended up doing is we took out the thing that had the smallest exponent. So if I'm looking at these two things, they both have an x in common. So now I can look at their exponents. And looking at their exponents, which one's smaller? Because that's exactly what I did up here in this first problem. So you can see that 0.5 is smaller than 1.5. So I'm going to rewrite this. I'm going to attempt to factor out the 0.5, and we're actually going to be able to do it. So you can see that this 1.5 here, it's like a mixed number. We have a whole, and then we have a 0.5, which is a half. Well, 0.5 being a half, since that's what I'm taking out, if I'm taking that half out, then I'm just going to have one left over. And then if I start with a half and I take away a half, then I'm just going to have nothing left over, which is really x to the 0, or you would just say a 1. So what we did there is we actually subtracted our exponents. So my scratch work would be dividing this thing by x to the 0.5 and dividing this thing by x to the 0.5. Let me change my color here. I'm not the best at going back and forth, so bear with me. And then I told you that we actually subtract those exponents. So if you didn't notice that, we really did 4 minus 2 up here, which is why we had 2 left over. 3 minus 2 here, which is why we had 1 left over. And then 2 minus 2 was x to the 0, but x to the 0 is just 1. So we're using properties of exponents when we're simplifying here. Now, instead of actually writing it like this, we could have gone back to writing it as fractions. Well, in terms of fractions, we would have written the 0.5 as x to the 1/2. So I'd have x to the 1/2 on the outside. And then, again, for the scratch work, let me erase all this, or actually, let me just move it down. We're going to divide everything by x to the 1/2. Now, I told you that we just subtract our exponents, and we can do this because the bases on these things are all x. So because the base here, these two have a base of x and you're dividing, you subtract your exponents. And then same thing here, if you're dividing here, you would subtract your exponents. So we end up getting, well, 3/2 minus 1/2. Well, I can actually do that because they have the same denominator. You can only add and subtract fractions if their denominator is the same. So 3 minus 1 is 2 over that same denominator, and then 2 goes into 2 one time, so that's all that's left over. So that would be my exponent, which we expected. That's what we got when we looked at it in terms of decimals. So here I have an x to the first power. And then I can see with this one right here, I have x to the 1/2 divided by itself. Yes, there's a negative. So it's a negative quantity divided by a positive quantity. We're just going to use the signs in front of those variables. But we have the minus, and then something divided by itself is always 1. So there is how you can factor out fractional exponents. Now, this example, we actually had like denominators. So let's do one more. And actually, let's say we have 2y. Actually, no, let's not use 2. Let's use 12y. No, I think I'm using multiples of 6 too much. Let's do 14. We'll say 14y to the, I'll say, 2/3. And then we're going to, we'll say, add 21y to the 1/3. Actually, let's make this a 1/2. Let's change it up. So if you want to think about this in terms of decimals, it's a good way to help you figure out how we're going to factor this. Now, just looking at the numbers, I see 14 and 21. I know both of those are divisible by 7. So I'm going to factor out a 7. But let's take a look at the variables. Well, 2/3 is really 0.6 repeating. And then we already know 1/2 is 0.5. So again, I'm just looking at, actually, well, we can just rewrite the whole thing. 21, say y to the 0.5. Now you can see that the smaller of the two exponents is the 0.5, so that means I'm going to factor out a y to the 1/2. And now I'm just going to do my scratch work. We're going to divide this thing by 7y to the 1/2. Divide this thing by 7y to the 1/2. So we have 14 divided by 7. Well, that's just going to be a 2. And then we have 2/3. Now the exponents, I'm going to subtract them. 2/3 minus 1/2. Well, you actually have to get common denominators, and you want to write them under the same denominator. If you'd like to see a video on how to add and subtract fractions, please let us know in the comments. So this is going to be equivalent to 4/6, and then this one's going to be equivalent to 3/6, and then you end up having 1/6. So when you subtract those exponents, you have a 1/6 left over. Now I'm going to do, we've got a plus here. We've got a 21 divided by a 7. Now, if I was dividing by a -7, this plus would change to a negative, but I'm not. So positive 21 divided by positive 7 is just 3. And then y to the 1/2 divided by y to the 1/2 is just going to be 1. So there you go. There you have it. There is how you can factor with fractional exponents. If you'd like to see some more examples, please let us know in the comments. Thanks for watching.